1 second.
She's got to get a
All right, so numerical integration and substitution. All right, so we have two choices when it's numerical integration and we need to use substitution. Choice number one, after integrating using a u substitution, you just substitute back for u and you keep the limits of integration, and then you just proceed as usual. And I have this in more detail later on in the notes for you. This is just sort of an introduction as to what your choices are. Or choice two, after integrating using u substitution, keep u, but use u to change the limits of integration. So either you go back to the old, you go back to whatever variable you had, you substitute back for that u, or you've got to change those limits of integration. You have one or two options. It really doesn't matter which one you do to me, which one, that came out right, which one you use, it doesn't matter to me. I tend to kind of switch it back and forth a little bit, and so sometimes it just depends on the function. I'm not consistent as to which method I use or which method is better. And so it doesn't really matter which way you use, but you should be able to use both, because maybe sometimes it might be easier to use one than the other. All right, so let's see how it works. This is just kind of one all kind of completed just to give you an idea, and then we'll go through a bunch of problems. Okay, and then I did not do, I don't have a separate homework on this. I decided I would do a classwork so that we could practice that. All right, so let's see how it works without recalculating limits of integration. So in other words, we're going to substitute back again. All right, so here u is x squared plus 1, and then we sort of have its derivative, right? So if we take the derivative of u and with respect to x, and of x squared plus 1 with respect to x, we're going to have du equals 2x dx. I don't see, however, a 2 there, right? There's no 2. But we can just divide both sides by 2 and make that 1/2 du equals x dx. All right, so 1/2 du is going to replace x dx, and u is going to replace x squared plus 1. So now we have over here, and so we're going to kind of, for a little while, not worry about these limits of integration, and we'll put them back, right? So usually we just drop the limits of integration when we're doing u substitution, if we're going to substitute back, because these limits have nothing to do with the u's. All right, so we have 1/2, because the 1/2 can come out, 1/2 u cubed du equals, and then we just integrate that. So that would be 1/2 u to the 4th divided by 4. It's just using the power rule. And now we substituted back. Right, so we replace the u with the x squared plus 1. We just multiplied the 2 and the 8 here. And now we're using our old limits of integration, which was from 0 to 2. So we plug in the 2, right, and we plug in the 0. And if we plug in the 2, we're going to get 4, plugging in 5 to the 4th, so that'd be 625 minus 0. And then we just multiply that by 1/8. So 6, oh, minus 1. I forgot all about the 1 over there. It's a good thing we didn't just put 0 in there. I almost forgot about the 1. So 625 minus 1. There's a 1 over there left. So that gives us 624/8, which reduces to 78. All right, so this is with replacing the u back again with the original function and keeping the limits. Here's the other one. We don't change, and we just keep the u, but we figure out the new limits, right? And so this is kind of a quick introduction, and then I'll go through it a little bit more slowly with all kinds of functions. So here we have sine to the 5th 2x, cosine 2x dx. The one with the exponent's got to be the u, right? If there was no exponent, it actually wouldn't matter who u was at all. You can pick either one of them. So sine 2x has to be the u, right? And that's going to be raised to the 5th power. We take the derivative of both sides, so the derivative of u would be du, would actually be du dx. They've already moved the dx over. And then the derivative of sine 2x would be a chain rule, so we'd have 2 cosine 2x, and we happen to have cosine 2x dx, but no 2. So we're missing the 2 again. So we will just divide both sides by 2, because that 2 is not there. So, and that's just a constant coefficient, doesn't matter. 1/2 du equals cosine 2x dx. So the 1/2 du is going to replace cosine 2x dx. The u is going to replace the sine 2x, so we're just going to have u to the 1/2 u to the 5th, which is over there. They write it kind of weird here. So it's 1/2 u to the 5th du. Now, notice those limits are different, right? They're not the same. So what you have to do is you have to rewrite it in terms of u's. So you're going to take your, you're going to use your u, and you're going to plug these values in for, into this u expression. And whatever you get, that's your new limits. All right, so we plug in a 0 here, we'd have sine 0, so that stays 0. If we plug in the pi eighths, we're going to have 2 times pi eighths is going to give us pi fourths. Right? And so pi fourths, that is that. And you're only looking for the one value. So you're not going to solve and get 2 values because, actually, I'm sorry, we're just solving here. So I'm thinking of arc sine where we'd get 2 values. So we're just plugging in for pi fourths. Sorry, I was thinking something else for a second there. So we have 1 square root of 2. It's just our 45, 45, 90 right triangle. And you can just leave it as 1 over square root of 2, or you can make it square root of 2 over 2. Doesn't really matter to me. And so now we're going to use those limits with our new function, and we won't substitute back. I need more. I think I'm tangled here. I feel kind of tethered. All right, actually,
babies.
we're going to move the computer. Oh, no, we can't. Oh, I'm stuck in this location. All right.
I'll write for you.
No.
Okay.
All right, so we're going to integrate u to the 5th du. That would give us u to the 6 divided by 6 du. All right, so, and then we would evaluate from 0 to 1 over square root of 2. All right, so now you got something really easy to plug into because you already did the work over here. All right, so this would just be 1/12 u, and then you'd have 1/12 times 1 over the square root of 2 to the 6th power minus 1/12 u, so that would just be a 0, right, because the whole thing's going to be a 0 to the 6th power. All right, so here you just raise each of them to the 6th power. This is going to be 1, and so this is this, if I, essentially, this is now the square root of 64. That's the easiest way to think of that one. So that's going to be 1/8. So 1/12 times 1/8 gives us 1 over 96. I kind of switched back and forth on the problem. I think I probably just change u more than I go back to the old one. I probably use that method more, but I'll leave it totally up to you.
So we can use either of those?
Correct.
Okay.
And so we're gonna learn both of them and go back and forth. All right. So and this you have this in your notes. So it just goes in a little bit more detail, and now I'm going to do the ones with you. It won't be up on the board already. So evaluating a definite integral where we have a u by substitution, where we have a u du substitution. We're going to make the substitution, right? So u is the function, du is the derivative with the dx. You're going to evaluate the resulting indefinite integral. You're going to substitute back and get the results in terms of x, or whatever it happened to have been, t's. And then you're going to substitute the limits of the definite integral into f and subtract. Right? So you're just going to go back, you're just going to be like you were writing the function, and then you're going to evaluate. Okay? So let's take a look at one of those. So here I have this one. We're going to evaluate the definite integral by substitution method 1. And you have this one in your notes. I hopefully gave you enough space. There's a lot of gray space around this because it's just how the problem went into the thing.
Oh yeah, it's in the bottom. Wow, that skipped.
Oh, did I?
No, that's
Yeah.
Oh, I guess it moved around. I'm sorry. It's supposed to be in order.
it's not.
Oh, well.
It also says we're supposed to use method 2 for this one.
Yeah, it also.
There should be one with a method 1, no?
No, it's not there.
No.
Oh wait. No.
No.
Wait, no.
Just
Oh, yeah.
write it in.
Yeah.
Write it in. We're going to do both methods then.
Can I just change?
Sorry, but I was tired when I printed these. Because I did both. I did the second set of notes first, and then I said, no, I really need to do this one first. All right, so what's our u going to be here? Yep. All right, so then we take the derivative, du dx equals, and this would be 2x, right? And then we don't have a 2, but we have an x. All right, so we're going to move the dx over. So du equals 2x dx. Just multiply both sides by dx, and then divide both sides by 2. So we have 1/2 du is going to replace the x dx, and then the u is going to replace x squared plus 2. I'm going to try to. I'm going to have to put my back to that side of the room. I'm sorry. So we'll have the, and so we're using method 1, which means we'll substitute back.
So you'll have u cubed?
Yes. So we'll have, and the 1/2 can come out. So we have 1/2, orientation problem here. We have 1/2 u cubed du. Right? And so we integrate. And so we have now 1/2 u to the 4th divided by 4. Right? And no plus c. Right? And now we can simplify that.
Why don't you have a plus c?
Because it's, well, I'll show you why it won't matter later on in the lesson. But yeah, we won't have a plus c on the definite integrals, only on the indefinites. Right? So now we'll simplify that. So we have u to the 4th power divided by 8. And then we're going to replace back again the x squared plus 2. Right? So we're going to have the x squared plus 2 to the 4th power divided by 8. And we're going to be evaluating it at our original limits there of 1 to 2.
So our derivative of that is
Can
x
I move any of
times
these?
x squared plus 2 cubed dx.
I'm sorry, say that again?
Yeah, okay, that makes sense.
I'm just going to move everybody so I have a little bit of space. And I may orient this board and not stop the tape. Or maybe I'll restart the tape. So now we just plug in. We have,
Don't restart the tape.
no, I mean stop the tape and start a new tape. This orientation is driving me crazy. 2 squared plus 2 to the 4th power. As you can see, orientation's being an issue today. So 2 squared plus 2 to the 4th power divided by 8
Can you like put this
minus
on and make it look like
1 squared plus 2
So like when Dylan looks at it, he just like
to the 4th power divided by 8. So sorry about that. All right, so that'd be 4 plus 2, that'd be 6 to the 4th power divided by 8 minus, and not 64, it almost looks like. So this would be 3 to the 4th power divided by 8. So this one here is 81/8. And then how about 6 to the 4th power? I know, 6 cubed.
What is that number?
to 120.
What's that?
Wait,
The
six-
x, or is it?
6 times
That's a 1 squared
Okay.
plus 2.
So they, okay.
208, 405.
So it'd be 216, it'd be 216 times 6.
What are we calculating?
1,000.
6 to the 4th.
200 and
1,296.
Okay, 1,296.
Yeah.
I thought I knew that too. 12968. So now we'll just subtract that. So that's going to give us 1215. 8.
which is 12.
That's not going to reduce.
I'm going to say, there's no way that reduces.
Yeah. The only factors of 8 are 2. All right, so here's one example. We're going to do some more examples right after I orient.
I was gonna say you should like put it on like repeat.